So hi friend, today as I told in the last class we are continuing the Fourier transformation. So today we will having the Fourier transformation and the Fourier series, that total name is called that Fourier analysis. So today we are having that Fourier analysis, that lecture 3. Today we will discuss some sort of mathematical problem on this. Maybe one more class is required for that. So first of all we should learn how to apply this Fourier analysis on different type of waveform that is given. So obviously what type of waveform we will be discussing right here, it all should be periodic in nature. So say for example question number 1. Now it is given that one pulse train which is varying from plus v to minus v. So it is v plus and that is v minus or minus v. So it is just going in this way. Now this is pi, this is 0, this is 2 pi, this is 3 pi, and in this way it is going on. I hope you cannot see it well. So please see this pi, 2 pi, 3 pi, the signal is varying from this. So finally we are having this type of problem, and you have to find out this is the axis of t and this is the axis of ft. So you have to use the Fourier transformation and you have to solve that. So how can I write the expression of this? So f of t equals to v for 0 to omega t, this is pi. Oh, it is omega t, so it should be omega t. Okay, and when it is lying to 0 to pi like this, so when it is minus v, so obviously it is lying from that minus pi to 0. Yeah, minus pi to 0. This particular section is also you are having like this type of waveform and like this. So it is the definition of that, the particular function. So here when I told you the Fourier analysis part, so I have told you that if the function is obviously odd in nature, here can say that is a odd in nature, so obviously it is a odd function. As you can see, that is a odd function. So odd function in the case of a0 and an, it should be 0, only bn exists. And what is the formula of getting out bn? That is 2 by t0 or 2 by t integration of, that is 0 to t, that is ft sine of omega t dt. This, sorry, it is n omega t dt. So this is a formula of getting out bn. So we may use that complex transformation also. So finally you have to write that particular form of that Fourier series in that basic expression of n equals to 1 to infinity, or that particular value n like this. So it should be c of n e to the power plus j omega t into n, that dt. So how to get that particular one of cn, how to evaluate this? So what is the formula of that cn? You know that cn equals to 1 by t0 integration of 0 to t. Here that 0 to t, what I am writing, that is 0 to 2 pi. Okay, so it is 0 to 2 pi. So it is 0 to pi, and another is, that is minus pi to 0. Okay, so it is, you have to write the definition right from here. So it should be, when it is 0 to pi, it should be v e to the power minus j omega t n dt, and it is minus v e to the power minus j omega n t dt. So if you are solving it, you will be getting the final answer like j into v by n pi into e to the power Jn pi minus 1. Okay, now for n is even, Cn equals to for n equals to even, Cn equals to 0 and e to the power jn pi equals to 1. Okay, so for n equals to odd, that Cn equals to, here 2v by n pi into j minus here. So if n equals to odd like this, so the final formula will be coming out like this. So if you are using this Fourier series, so what is the final expression? That ft can be evaluated as j 2v by here odd, so 3 pi e to the power minus, there is j omega t into n, so it is 3j omega t, again that next one, that is j into 2v by there j equals to 2 pi plus here 1 also, so maybe 1 e to the power minus j omega t and so on in this way. So here we will be having another problem, that is given as one sawtooth function like this. So it is a, it is 0, it is 2 pi, it is 4 pi, and that is a function of omega t scale, this is a ft scale. So you have to find out the Fourier series of that given waveform. So how to do this? Here we can write the expression of this as f of t equals to a by 2 pi into omega t. Here it is given as ft equals to a by 2 pi into omega t for 0 omega t 2 pi, that is a range here. So this is a function definition I have made. Now how to get that same complex frequency Cn? So how to get that? 1 by t0 or 1 by t0, here it is 0 to t0 f of t e to the power minus this is j n omega t. So you can change that. So in this particular problem, that ft is given here and e to the power j n omega t into dt. So just replace it right here. So it should be 1 by 2 pi, the total time period is this. Here it is 0 to 2 pi, the total time period, and this is a by 2 pi into omega t into e to the power minus j n omega t dt. So this part is constant term, it will be coming outside, so it should be a by 2 pi whole square into that omega t, say here it is not dt, it is d of omega t. So finally what is the output we will be getting here? It is e to the power minus j omega nt by j n, that square, which is multiplied with minus j omega n t minus 1. So it should be the third bracket actually, and the final answer will be 0 to 2 pi. It is integrating within the range of 0 to 2 pi, so the final answer will be j by 2 pi n into a with that minus sign. So you can easily write that Fourier series by this. How to do that? F of t equals to integration of n equals to minus infinity to plus infinity, the complex series definition, that is Cn e to the power j omega t into n. So if you are writing in this way and placing this coefficient of that, so the final series is here j a by 2 pi n with a minus sign, that is n equals to minus infinity to plus infinity of e to the power j omega t n. So finally you'll be able to find out the entire series. All we are having that minus, and they are approaching in this way. Here n equals to 1, n equals to 2, n equals to 3 in this way. So actually we should not take it in outside of that, we should place it inside. Then it is a by 2 pi, a by 4 pi in this way. The entire series will be running on like this, minus j a 2 pi e to the power j omega t minus j a n equals to 2, so 4 pi e to the power j 2 omega t. In this way we have to complete the entire series. Now here another problem is asked. As you can see, this is that is question number 3. Here one waveform is propagating in this way, that is plus 1 to minus 1, and it is varying in this way. So that is given as pi by omega, that is 2 pi by omega, and that is minus pi by omega, and so on. So this is the t axis, not that omega t axis. So please follow before doing the problems that whatever the axis is given, whether it is ft or t. Now what is the definition of the function? As you know that we have to write it first, that ft equals to 1 for minus pi by omega to 0, this, and ft equals to this is sorry, ft equals to 1, this is 1, so 0 to pi. So it is, if it is like this minus pi to 0, it should be minus 1 like this one, and if it is 1, so that ft is lying between that range. Okay, so there is a range. Now how to find out that coefficient? Say what is Cn, that is integration of 1 by t, that is 0 to t. Here it is f of t e to the power minus j omega nt dt. So here it is t is a time period is minus pi by omega to plus pi by omega, and this is 2 pi by omega total. So 1 by 2 pi by omega, so it is omega by 2 pi, right? So it is omega by 2 pi integration of minus pi by omega to plus pi by omega. So here in this particular given problem, the limit is given, and this is f of t. So I can again write f of t e to the power minus j omega nt dt. Okay, so it is minus pi to 0 and 0 to plus pi by omega. minus pi by omega to 0, 0 to, so two different definition is being created. So finally it can be written as, you can easily write it that omega by 2 pi, that is minus pi by omega to 0, minus pi by 2 omega to 0, it is minus 1, so it is minus 1 e to the power minus j omega nt dt with a third bracket plus integration of 0 to pi by omega 1 into e to the power j omega nt dt. Okay, now this is 1 e to the power j theta. It means you can write it as you know that e to the power j theta equals to cos theta plus j sin theta, and e to the power minus j theta means cos theta minus j sin theta. So if you are subtracting them, so only the sine part will be lying, so the function will be coming as sine. So if you are converting the sine, it is integrated out, so it will be generating one cos function. So the final answer of the integration, you can evaluate it by yourself. It is by putting this value also, it is 1 minus cos of n pi divided by j n pi. Now so Cn equals to 0 for n equals to odd, otherwise you will be getting the entire Fourier series by using this particular term. You can easily expand it in the form of summation of Cn e to the power j omega nt n equals to minus infinity to plus infinity, that is a Fourier series f of t, that is a periodic function, and this is also the periodic function. We are just converting it to that scope of sinusoidal analysis, so that particular periodic function is converted in that Fourier transform here. So now we will be having another new sort of mathematical problem, which is giving at question number 4 like this. So one periodic pulse train is given, that is t by 2 to t, that is 3t by 2 to 2t, and so on. So you have to find out the Fourier transformation, you have to find out the Fourier series of this given waveform. So what is the definition? That f of t equals to 0 when it is lying between t to t half. So it is lying 0 to t half, and obviously it should be, if it is taken as a, so it is a for when it is t half to t, that is the range. So we have to find out the Fourier series. So how to find out? You simply just calculate a0, an and bn. So what is a0? a0 equals to 1 by t, or 1 by t0 you can write it, that is integrating from 0 to t. Here you have to integrate it from t by 2 to t. Why? Because if you are integrating in this way, that 1 by t integration of 0 to t ft dt, so here 0 to t half it is 0, and t half to t it exists, so I am taking this particular integral actually. So here if you are putting this value of ft, which is a, right here, so it will be giving out the expression of a by 2. If you are putting the value for an equals to 2 by t0 integration of t1 to t1 plus t0, that is ft cos of n omega 0 t, so it is simply out of 0. You can integrate it out. Now if you are finding out the Bn, the same formula, 2 by t0 t1 to t1 to t0, that ft sine of n omega 0 t dt. So if you are integrating out, finally it will be coming as a by n pi and cos of 2n pi minus cos of n pi. So it is a by n pi, you can write it a by n pi into 1 minus 1 whole to the power n. So if n equals to even, this part is 0, but if n equals to odd, this part is simple 2a by n pi with a negative sign. Okay, so finally, considering the odds, you can easily construct the full length of the Fourier series. So finally the Fourier series will be coming as ft equals to, that is a by 2, so it is a by 2 minus, here that is 2a by pi, you can take it as a common, so 2a by pi if you are taking as a common, so it is sine of omega 0 t plus 1/3 n equals to 3, we are taking the odds, so sine of 3 omega 0 t and plus so on. So that is a total function of this. So before leaving out this particular one, I think that more examples should be analyzed in the next lecture of myself, and obviously more questions regarding this Fourier series will be extended in this particular lecture. And good day, have a good luck, and see you very early next in my next class of the Fourier transformation. Thank you.